Welcome to this section of this course. Today it's regarding integration by partial fractions. Okay. In these partial fractions, what we have to do is, you can see over here, the degree of denominator is same as degree of numerator. Okay. Here also degree of numerator is same as degree of denominator. Okay. All four sums. Okay. In this type, what we have to do is, we have to divide by denominator of each numerator. Okay, by division algorithm. Okay. Let's see solving question number 1. What we have is integral of x square plus x plus 3 upon x square plus x minus 6 dx. Okay, let's consider, you have to divide by this. Okay, here simple algorithm, okay, of division, plus x minus 6. Here we have x square plus x plus 3. Here 1. Okay, if I multiply 1 here, I will get x square plus x minus 6. Okay, here if I minus inside, x square gets cancel, this gets cancel. What I have, minus plus 9. Okay, so this is same as here 1, remainder is what, plus 9. Okay, plus 9 upon x square plus x minus 6. Okay, this can be written as this. Okay, here dividend divisor, division quotient, this is remainder. Okay, here this is, I can say like this, here integral of this. Okay, now separating integral of the dx is what, we have x plus 9 outside, integral 1 of here x square plus x minus 6. Okay, now here x square plus x minus 6. Okay, can you get something here? Here we have minus 6 divided by, if I can you break this middle term, x square minus, here if you have 2 3, just check it. Okay, here we need to get plus. Okay, minus 2 into 3 is what, minus 6. If I add these two, I am getting plus 1. Okay, so I can write 2x plus 3x minus 6. Okay, here you have to search two numbers such that if you multiply, you should get minus 6. Minus 2 into this is minus 6. If I add these two, I am getting 1. Okay, here if I take x common, x minus 2 plus 3 common, x minus 2, this is same as x plus 3 x minus 2. Okay, this is same as x plus 3 into x minus 2 dx. Okay, now let's consider this for partial fraction. Okay, for partial fraction, if I consider this, so 1 upon x plus 3 x minus 2 is equals to, let's use some constant a upon x plus 3 plus b upon x minus 2. Okay, now multiplying these on both sides. Okay, what we have is this one gets cancelled. We have 1 is equals to a into x plus 3 gets cancelled. We have x minus 2 plus b, x minus 2 gets cancelled, and we have x plus 3. Okay, now if I am putting x equals to 2 in this equation, okay, in this equation, so this will get 0. On the left hand side, I have 1 is equals to, on the right hand side, when x equals to 2 is 2 plus 3 is 5. 5 into b is implies b equals to 1 by 5. Okay. Now if I substitute x equals to minus 3 in this equation, on the left hand side I have 1 a into minus 3. Okay, minus 3 into minus 2 is minus 5. Therefore a equals to minus 1 upon 5. So I'm getting a and b over here. Okay, so a is what? Minus 1 by 5 minus 1 upon 5. B is 1 upon 5. Okay, so integration of this is become integral of this is become integral of this, integral of this, integral of this, dx, dx, dx is equals to minus 1 by 5. Outside there will become what? Log of x plus 3 plus similarly 1 by 5 log of x minus 2 plus some constant. This is what? This is okay. And this term, therefore, x plus 9 into whole this, okay? 9 into minus 1 by 5 log of x plus 3 plus 1 by 5 log of x minus 2 plus c is the required answer for question number 1. Now, next question, okay? Here. Hello. Now next question number 2. Okay, let's see. Question number 2, integral of x cube minus 1 upon x cube plus x dx. Okay. Now here the degree of numerator is what? 3. As well as denominator is what? Denominator and numerator both are 3. Okay, both are same. Okay. Now what we have to do is we can take x common over here. If I take x common, then it will be x square plus 1. Okay. So let's do one thing. Let's divide here x by simple logarithm, simple division algorithm. X cube minus 1. Here I will get x cube plus x. Here negative multiplying. Okay. Now x cube gets cancelled. Here I will be having minus x minus 1. Okay. This is same as if I take minus common x plus 1. Therefore this can be written as what? Integral 1 minus x, this is remainder, upon x cube plus x dx. Okay, the integration of 1 dx is what? X. Okay, now this part is over. Now let's consider x plus 1 upon x cube plus x. Okay, this is same as if I take x common here, then x square plus 1. Okay, this is now here, this is same as I can write by partial fraction a upon x plus, since x square is there. Okay, if it is x square minus 1, then I can say a square minus b square. We have a minus b into a plus b. Okay, since plus is there, so we have to choose two constants. A is already chosen, bx plus c upon, here you have x square plus 1. Okay, now let's consider this part. If I consider this part, okay, then multiplying this on both sides, what we have is x plus 1, because this term and this term gets cancelled, is equals to a into x gets cancelled. We have x square plus 1 plus bx plus c into x square plus 1 gets cancelled. We have x. If we expand one more, we'll get a x square plus a plus b x square plus cx. Now, in this equation, if I substitute x equals to 1, okay, x equals to 1, then we will not get values of either a, b, c. Okay, so let's do one thing, comparing various powers of x. Okay, so comparing coefficient of x square. Okay, if I compare coefficient of x square on the left hand side, there is nothing. Okay, here you can say 0, here a plus b, here we have a plus b, therefore a equals to minus b. And if I compare coefficient of x is what? Here 1, we have here equals to here x, here we have coefficient of x is what? C. Okay, therefore we have the value of c is, we have 1. Okay, and then constant term. Okay, constant term is what? You can say constant term. Constant term on the left hand side, what we have? 1 equals to here a. Okay, here a we have a equals to 1. We have, since a equals to minus b, therefore b will be minus 1. Now substituting all these values here, okay, here what we'll get? This I will remove this we have here we have integral of 1 minus x plus 1. Okay, so I will remove. Okay, I will substitute directly over here. Okay, here a is what? A is 1. Okay, so I will write here a is 1 and b is minus 1. Here I will write minus x. C is 1. Here I will write 1. Okay, after substituting, what we'll do? We'll integrate. Now integration of this, okay, integration of this is equals to integral 1 by x dx plus integral minus x plus, here I can separate also. Okay, here minus x upon, I can separate this, minus x upon, we have x square plus 1 plus and 1 upon integral x square plus 1 dx. Okay, here already we have here integration of x is what? Integration of 1 dx is here x minus. Okay, this we have. Okay, but here we have minus over here. Okay, so we have to have minus here. Okay, so is equals to x minus integral of 1 by x is, we have log of x plus, so I can send this minus outside. Okay, here I will send minus outside, it will become a plus minus. Now d by dx of x square plus 1 is what? Twice x. Okay, so I need 2, so I am cancelling with this 2. Okay, so it will be half log of x square plus 1 and then plus this is, or from integral of x square plus a square is 1 by a, means 1 by 1, then inverse x by a means x. Okay, plus c. Okay, this is the required answer for question number 2. Now question number 3 is x square upon x square plus 6x plus 12. Okay, now look at here, can you factorize this? Okay, let's try it. If you are able to factorize it, it will be an easy one. Okay, let's see. 12 if I back 2 6 are 2 3 are 4 and 3, 4 plus, we need two numbers such that if you multiply we should get 12, if you add we should get 6. So if I combine 4 and 3, 7, not possible. If I combine 2 and 6, not possible. Okay, so it's not possible. Okay, therefore we have to divide this. So let's divide x square plus 6x plus 12 upon here x square. Here 1 we have x square plus 6x plus 12. This is simple division algorithm. Okay, minus we have this x square cancel, minus 6x minus 12. Okay, after that you cannot do. Okay, therefore this I can do one thing, I can take my even minus also. If I take minus common, this will be 6x plus 12. Okay, therefore this can be written as 1 minus 6x plus 12 upon x square plus 6x plus 12 integral dx. Okay, now integration of 1 dx is, we know it's x minus we have. Okay, now look at here. Okay, now integral of 6x plus 12 upon we have x square plus 6x plus 12. Look at here. Okay, if what is this, if you differentiate denominator, what you have, if you differentiate denominator, what you have twice x plus 6. Okay, twice x plus 6, you need twice x plus 6. Okay, so in order to get twice x plus 3, if I take 3 common, okay, so from here if I take 3 common, this is equals to integral x minus, if I take 3 common, then we need 2. Okay, so if I take 3 twice x plus 6, 4 3s are 12, 3 2s are 6. Okay, upon x square plus 6x plus 12. Why I'm taking 3 common? Because differentiation of x square plus 6x plus 12 is what? We have twice x plus 6. In order to get twice x plus 6, first try to get twice x first. Okay, so twice x. So in order to get twice x, from here we need to take 3 common. If I take 3 common, then 3 2s are 6. So if I'm taking whole, so 3 4s are 12. Okay, but I need to get twice x plus 6. Twice x I already have. Okay, so what I can do is, in order to get 6, okay, here I can add plus 2 minus 2. Okay, so this become one term, this upon this. Okay, therefore this integration of dx is get over. Now x minus 3 integral twice x plus 6 upon x square plus 6x plus 12 minus. Okay, here 4 plus 2 6 twice x, we have 3 outside, 2 integral x square plus 6x plus 12 dx, here dx. Now x minus 3, so therefore integration of this is what? We have log of x square plus 6x plus 12 minus. Look at here. Okay, let's make an perfect square. Okay, look at here. We have x square plus 6x plus 12. Okay, now let's make of the form a plus b the whole square. Okay, here x square I can say is twice x, I can say in order to get 6 3 plus I need to get it become what? Twice ab. So since I already assigned 3, so I need to get 3 square, because x square a square plus twice ab plus b square. Here 2 into x into 3 is 6x, 3 square is extra. Okay, plus 12. Okay, 3 square is 3 3 is 9. Okay, in order to get 9 10 11 12. Okay, here you can say plus 3 is c. Here 3 square, 3 is a 9, 9, 10, 11, 12. Okay, now this become what? This become x plus 3 the whole square plus 3 is same as root 3 the whole square. Okay, therefore instead of this, okay, instead of this, what I can write is, instead of this term I can write x plus 3 the whole square plus root 3 the whole square. So we have the formula x square plus a square. Okay, so is 1 by a means I'll get here 2 already outside into 1 by a means 1 by root 3 formula 10 inverse x by a, x plus 3 upon root 3, okay, plus integral, okay, plus some constant. This is the required answer. Okay, because we have 1 upon x square plus a square is 1 by a, 10 inverse x by a. Here this is x, here our a is what? Root 3. Okay, now next question is for, let's see, for question we have x square plus 1 upon x square minus 5x plus 6 dx. Now numerator as well as denominator order are same. Here x square, x square. What we can do is we can divide this by this, or if it is possible we try to get try to split this. Okay, let's see whether it is splittable or not. Consider, if I consider x square plus minus 5x plus 6 equals to 3 and 2. Okay, here I can say x square minus 3x minus 2x plus 6, 3 and 2. I am choosing minus 3 and minus 2. If I multiply these two, I am getting plus 6. If I add these two, getting 5, minus 5. X common, x minus 3 minus x, x minus 3, check it. Here 2. X square, 3x, twice x minus s plus, this is x minus 2 into x minus 3. Okay. Now instead of this, I can write like this. Instead of this, I can write the x square plus 1 upon x minus 2, x minus 3. Okay. So is same as a upon x minus 2 plus b upon x minus 3. Okay, now multiplying this same way, multiplying x minus 2, x minus 3 on both sides, we have x minus 2, x minus 3, this gets cancelled. What we have is x square plus 1 is equals to a, x minus 1 and x minus 1 will get cancelled. So I will have x minus 3 plus b into x minus 3 will get cancelled, x minus 2. Okay, now if I substitute x equals to 2, then b will get 0 and I will get the values of a. Okay, so putting x equals to 2, we have on this equation. Okay, x equals 2 in this equation. Now here 2 square plus 1, 2 2s are 4, 4 plus 1, 5. A into 2 minus 1 is minus 2 minus 3. Here 2 minus 2 become a 0. Okay, so we don't have to write anything. It implies 5 equals to 2 minus 3 is minus 1, it's minus a, therefore a equals to minus 5. So we have a equals to minus 5. Similarly, if I put x equals to 3, okay, if I put x equals to 3 over here, so 3 3 is a 9, 9 plus 1, 10. Okay, 3 3 is a 9, 9 plus 1, 10. Here this term gets 0 because 3 minus 3 is 0, 0 into a is 0 plus b here 3 minus 2 is implies 10 equals to b into 3 minus 2 is 1. So therefore 1 into b is b. Okay, therefore 10 equals to b. Now substituting in this equation, okay, say equation number 1, a values of a and b. So what we have is what? A is minus 5 upon x minus 2. So let's take integral over here. If I take integral, then integral dx integration of x, integration of this is same as this. Okay, so integral dx plus what is b? B is 10, integral 10 upon x minus 3. Now minus 5 I can send outside. If I send outside, then that become a integration of this is log of x minus 2 plus 10 outside. Since this constant, integral of 1 upon x minus 3 is log of x minus 3 plus c. Okay, this is the required answer for question number 4. Now these are two integrations we need to solve with the help of partial fractions. Okay, now in this scenario you see here this is x square. Each and every terms you can see x squares are there. Here also x square, here also x square, x square, x square, x square, x square. Sometimes they might give you x cube or x5, x5, x5. Okay, here maybe any. Okay, this if it is x5 then x5, x5. If it is x6 then x6, x6. Okay, now here you cannot substitute, you cannot do putting over here. Okay, now if I substitute, for example, this is just assumption. Okay, now let's solve this. How it works? X square minus 2 upon x square plus 2 upon twice x square plus 1. Okay, now they have to consider something assume, or that's called, I call assumption. Okay, assume x square equals to m. Okay, so now if you substitute, for example, before what we did is, for example, if I substitute t equals to x square, then dt equals to twice x dx. So we don't have twice x dx over here. Okay, this time in this scenario we have to just assume. You don't have to differentiate this and substitute over here. For time being, you have to substitute assume. Okay, you have to do assumption. Now assume is equals to m, and integration this become what? Here m minus 2 upon m plus 2 into twice m plus 1. Okay, now from here, so we have what? M order of denominator is what? 2. Okay, here m square we have, here m, therefore it is a proper fraction, so we can apply partial fraction. These are linear as well as non-repeated, so I can say a upon assign m plus 2 plus b upon twice m plus 1. Okay, same as multiplying m plus 2 into twice m plus 1 into the both equation. Okay, into the both equation, what we have, m plus 1 twice m plus 1 will get cancelled. We'll have m minus 2 is equals to a into m plus 2 and m plus 2 get cancelled. We'll have twice m plus 1 plus b. We'll have twice m plus 1 will get cancelled. We'll have m plus 2. Now if I substitute m equals to minus 2, then I will be getting the values of a. Okay, so let's substitute, putting m equals to minus 2 in this equation. We have minus 2 is equals to a into minus 2 into 2 is minus 4 plus 1, and here minus 2 plus 2 is 0 into b is becomes 0. Okay, it implies minus 2 is what? Minus 4 is equals to, here minus 4 plus 1 is minus 3. Okay, minus 3a. Okay, here minus 4 and minus gets cancelled. Okay, therefore a equals to 4 by 3. I can send this 3 down. Okay, therefore we have a is 4 by 3. Okay, now if, okay, look at here. Okay, 2m plus 1. Okay, now I want to remove this. Okay, so what is 2m plus 1? 2m plus 1 equals to 0. You find m. Okay, twice m equals to minus 1. Therefore m equals to minus 1 by 2. Okay, now if I substitute m equals to minus 1 by 2, then this will be minus 1. We already have plus 1. Okay, minus 1 plus 1 will get cancelled. It becomes 0. 0 into a become a 0. So I will get the values of b if I substitute m equals to minus half. Okay, therefore again if I substitute m equals to minus half, how it is coming? Look at here. Okay, twice m plus 1 equals to 0. From there you can find m. Twice m equals to minus 1, m equals to minus 1 by 2. Okay, so m is minus half minus 2 is equals to, this become a 0 plus equals to b minus half minus plus 2. Okay, take LCM. We have 2 minus 1 minus 2 to the 4, b minus 1 here plus 2 to the 4 upon 2. Okay, these 2 and these 2 gets cancelled. Okay, these 2 and these 2 gets cancelled, and what we have, minus 1 minus 4 is what? Here what we have, minus 5 is equals to b. Here is what? Minus 1 plus 4 is 3. Okay, therefore we have b equals to minus 5 by 3. So we have the values of a and b. Substitute over here. Okay, so what is value of a? A is 4 by 3. We substitute here 4 by 3. And what is b? B is minus 5 by 4, minus 5 by 3, minus 5 by 3. Now we have this. Okay, after substituting values of a and b, we have this. Okay, now you come back. What is this? Okay, this is same as integral of this. Okay, you can say integral of this is same as this. We can say this equals to, let's write integral over here, dx integral. Okay, I will write next step. Okay, this is same as 4 by 3. I am taking outside 1 upon, what is this, x square plus otherwise let's do one thing, substitute this. Okay, here x square plus 2 dx plus minus 5 by 3. Here what we have is 1 upon 2x square plus 1 dx. Okay, now it is here what we have, 2 is same as, I can say root 2 the whole square. Okay, now 4 by 3 integration of this is 1 by a tan inverse x by a minus, here x is x, a is root 2. Okay, here I want to get free of x square, so I can take, consider here 2x square plus 1. If I take 2 common, I will have x square plus what, 1 by 2. Okay, so this is same as 2x square. If I want to write 1 by 2 is same as 1 by root 2 the whole square. Therefore this is same as, instead of this I can write this. Okay, I can write this. So this is same as 5 by 3 integral 1 upon, I can send these 2 outside, 3 into 2 x square plus 1 by root 2 the whole square dx. Here 4 upon 3 root 3 tan inverse x by root 2 minus 5 by 3 into 2 is what? 6. This is again tan inverse 1 by a is 1 by root 2, tan inverse x upon root 2 plus some constant. Okay, here what we are using is what? 1 by a x square plus a square is 1 by a. We are using this formula, 1 by x square plus a square dx is 1 by a tan inverse x by a plus some constant. Okay, this formula we are using over here. Okay. Now similarly over here, this also, here we have x square or x square, so we need to assume x square equals to t for time being. Okay, do not differentiate this with respect to x because we don't have x dx. Okay, so for time just assume, or you can say consider x square equals to t. Then now it become what? T upon t plus 4 t plus 9. Okay, now this is same as, now this becomes same as what? Question number 1. Okay, now here we'll use some tricks. Okay, tricks to solve what? This partial fraction. Okay, this is same as, now you want to find the value, if I consider, okay, when I consider t equals to what? Minus 4. Okay, if I put t equals to minus 4, this term will go. Okay, now substitute over here those terms which do not have t equal plus 4. Okay, now this is applicable only when these two are linear as well as non-repeated. Since it is linear as well as non-repeated, we can use this trick. When t equals to minus 4, okay, this term will be gets cancelled. Now substitute minus 4 here. We have minus 4 upon here minus 4 plus 9, and then take log of differentiate of, now integral of, you can say integral of 1 by t plus 4, or you can say that you can put directly log of, you can say log of, or you can put for time being integral 1 upon t plus 4 plus, when you put t equals to minus 9. Okay, now this term will go. Okay, this term will go. Therefore minus 9 upon minus 9 plus 4 integral this. Okay, 1 upon t plus 9. This implies what we have? Minus 4 upon, here we have 5 integral 1 upon, what is t? T is x square plus 4 dx plus this term. Okay, here minus, we have minus 9, here minus 9 upon, here we have minus, here minus 5. Okay, minus minus plus 9 by 5 integral 1 upon t is x square plus 9. Okay, so 4 is same as, I can say 4 is same as what? 2 square. 9 is same as 3 square. Okay, now therefore this is same as minus 4 upon 5. This is x square plus a square is 1 by a, 1 by 2 tan inverse x by 2 plus 9 by 5, 1 by a means 1 by 3 tan inverse x by 3 plus some constant. These are tricks which we are using, which I am using. Okay, or you can say instead of this, what you can say is you can do by a upon t plus 4 plus b upon t plus 9. Multiply this, the same process as 1, so you will get the same answer. These are tricks which you can get the answers very quickly.